Okay, we are starting a new chapter. This section is entitled Quadratic Functions and Applications. I'm going to tell you that up until now we've done what are called linear functions, right? That was last chapter. So I'm going to do a quick recall. What does it mean to have a linear function? A linear function is of the form f of x equals ax plus b, where a is not 0. What makes it linear? It's x to the first power. And the graph of a linear function is a line. Yep, that's what we did last chapter. Okay, now we're going to move into what are called quadratic functions. And I'm going to go introduce vertex form in just a second. But a quadratic function is of that form, f of x equals ax squared plus bx plus c. Again, that leading coefficient a cannot be 0. What makes it quadratic? It's the x squared term. That makes it quadratic. By completing the square, you can express that in what's called vertex form. And here's possibly a new concept. Vertex form is given as f of x equals a times quantity x minus h squared plus k. So my question to you is, how do you go from this form to this form?
Complete the square.
You're going to go complete the square. I'm going to show you how in just a second by doing it with an example. I can show it to you with the A, B's, and C's if you want me to, but yesterday everybody kind of glossed over when I was doing that. So we're going to do it with an example. Okay, if you're given vertex form, again, this form, you can look at that equation and tell me immediately what the vertex is. It's hk. Now look in your equation. You see it's x minus h. So if you had x minus 2, the x-coordinate of your vertex would be positive 2. If you had x plus 5, your x-coordinate of your vertex would be negative 5. Exactly. Now your k is just out here as plus k. That's your y-coordinate of your vertex. Some things to notice. That a out front, if it's positive, the parabola is going to open up. If that a out front is negative, the parabola is going to open down. Okay, the rest of those statements, if you have a parabola that opens up, are you going to have a relative min or a relative max? You're going to have a relative minimum. It's at the bottom of a valley. That vertex is going to be your relative min. If you have a parabola that opens down, so a is negative, the vertex is going to be a relative maximum. Okay, on any vertex, you can split it in half, right? That line that goes through the middle of the vertex is called an axis of symmetry. And the axis of symmetry, it's a vertical line, so it's going to be x equals a number, and the number it equals is the x-coordinate, x value of the vertex. So it's x equals h. There's a lot of information in that box. Looking at a parabola that opens up, like this one, what can you tell me about the leading coefficient a? It's greater than 0. A's got to be positive. That vertex down here, hk, is going to be a relative minimum. And you're going to have an axis of symmetry, x equals h. Okay, let's go look at an example. Let your function be y equals x plus 3 quantity squared minus 1. First question, what is your a that's out front?
1.
It's a positive 1. So is that graph going to open up or down?
It's going to open down.
Careful, a is positive. It's going to open up. So your graph is going to look like this. Can you identify the vertex?
Yes.
I'm looking here and here. So my vertex is going to be negative 3, negative 1. And it's going to be a minimum. Yep, question? Why is it a minimum? Because the parabola opens up.
Okay.
The vertex is going to be at the bottom. So I'm going to write down it's going to be a relative minimum. Okay, to find the Y-intercept. For a Y-intercept, you always let x equal 0. So if I let x equal 0, I'm going to get y equals 0 plus 3 squared minus 1, which is 9 minus 1? 8. So my y-intercept is the point 0, 8. Now find the x-intercepts. How do you find the x-intercepts? You let y be 0. So I have 0 equals x plus 3 squared minus 1. How do I solve that? I'm going to move 1 to the other side. Then I'm going to take the square root of both sides. When I do that, I have to put plus or minus out front on the left. So I get plus or minus 1 equals x plus 3. Subtracting 1 from both sides, I get plus or minus 1 minus 3 equals x. Okay, if I say it's the positive 1 here, I get 1 minus 3 equals x, correct? So x is negative 2. If I say it's the negative 1, negative 1 minus 3 is negative 4. So I have two x-intercepts. What are they? Negative 2, 0 and negative 4, 0. I'm going to pause and let you catch up. Okay, letter E. Go sketch the function. Let's go sketch those 4 points that we just found. The vertex is at negative 3, negative 1. Right here. The y-intercept is at 0, 8. So I'm going to go add, hold on. I'm going to go add some tick marks. 2. So negative 3, negative 1 is here. 0, 8 would be here. And my x-intercepts were at negative 2, 0 and negative 4, 0. My function would look like this. Does it open up? Yes. Is there a relative minimum? Where is the relative minimum? Negative 3, negative 1. How many x-intercepts are there? 2. They're at negative 4, 0 and negative 2, 0. Okay, the axis of symmetry. Where is it? It's at x equals, right here, x equals negative 3. Determine the max or min value. It's going to be a minimum value. And what is the minimum value? Not where is it, what is it? It is negative 1. Yep. Axis of symmetry is the vertical line that cuts the parabola in half. The axis of symmetry is the vertical line that's going to cut the parabola in half. And it's going to go through your vertex right here. So it's going to be x equals whatever the x value of your vertex is. Determine the max or min value. It's the y value of your vertex. State the domain. What's the domain of any quadratic? All real numbers. Last but not least, state the range. What y value do you get to start? Bracket -1 up to infinity.